and how are you doing? It's another edition of Problem Corner. Actually, the solution to Problem Corner, the actual problem, will appear in the September 2023 newsletter number 21 put out by the International Group for Mathematical Creativity and Giftedness. They've been around since 1999. You can find their website at IGMCG.org. You can read there a mission statement along with a letter from the president. The newsletter is put out by Scott Chamberlain as the editor and Chris Weiss assisting in that regard. I just wanted to thank them as well for letting me be a part of this and do this Problem Corner. It's a really neat idea to collaborate with them, and I am honored and privileged to do so. You should check their website out if you are interested in the instruction of math and expanding creativity, nurturing the growth of it within mathematics around the globe. Then you should definitely go to their website and see. They do have a place on there where you can maybe submit a suggestion for an article. You can also join in membership on their website. I would encourage anyone, again, who likes math and likes creativity and the support of that endeavor to go ahead and check them out at your leisure. For the audience that's coming from the newsletter, I will be explaining this solution to an audience that's wider than you. And some of them might not know this symbol, so I will add a few details as I work through this solution. Let's get to that solution now. The source is the 2014 American Mathematics Competition for grades 12 and below, the A test. There's two, an A and a B. It's problem number 21. And this test is the first leg for most people in their journey if they're trying to reach the International Math Olympiad within the United States. It's also open internationally as well. People from all over the world do take the AMC. I believe they can even take the second round, the American Invitational Math Examination, which this test you can qualify for that other test. The invitational comes from your qualification here, or there's a few other ways you can do it as well. Let's get started and work through it. For every real number x, let this symbol, which is the greatest integer less than or equal to x, it also has other notations. It can look like this. It can also look like this. But they all have the same meaning, and they'll state it here as it will denote the greatest integer not exceeding x. So if x is an integer, again, speaking to an entire wide audience here, if x is an integer, then it's less than or equal to itself, right? It's equal is okay, not exceeding. 4 does not exceed 4. We allow it to stay as is. However, no matter how high that number gets, 4.99 doesn't matter. It's going down to 4. That is how that concept works. It's also called the floor function because, again, no matter how the distance between your floor is, you're going down to the floor, as opposed to another function we call the ceiling function, in which you would round up unless you're on an integer, and then you would stay there. Okay, so let's get started. And let f of x, or continue, equal the greatest integer less than or equal to x times 2014 to the power of x minus the greatest integer less than or equal to x minus 1. Okay, so again, this is going to be a little overwhelming for a lot of students. They're going to see it and go, wow, I don't even know where to begin or what to do with that. And so what I advise them to do is just ignore it. I mean, don't think about it right now. If you see something you can do, of course, act on it. But we might not know what we're going to be doing with this. We don't have any idea of how to apply it. So the best thing to do is just glance at it and go, and let's just read this and then maybe form a plan of attack. The set of all numbers x such that 1 is less than or equal to x, which is less than 2014, and f of x is less than or equal to 1 is a union of disjoint or not connected, they have no overlap, intervals. What is the sum of the lengths of these intervals? And so again, the reason why I chose this problem for this edition and why I liked it so much, I came across it in my recent class that was reviewing past tests on AMC 12. By the way, if you're interested in those classes, my website will be in the description as well, and you can inquire about those via it. And so I'd never solved it before. And so I got to kind of experience it for the first time, and I really liked it because it feels like, man, like I said, you don't know where to begin, you don't know what to do or how to attack it. And so what I tell students to do at that time is, you're a scientist in a lab. Start doing experiments. Start doing basic things. Don't worry about the end game or how you're going to get from here to the finish line. Just worry about what's one thing you could do. And then from there, we'll continue to refine our approach as we gather information from these little experiments that we conduct. And then we'll put those pieces of information together, make a new hypothesis, and restart the scientific method, if you will, in that way. So when I look at this here, many of you probably know exactly what this is. I will explain a little bit more about it. If you take a number x, you can say that it's equal to its greatest integer less than or equal to x plus we call it the non-integer portion of x, the fractional part of x is what we would call it. So if it was the 0.99, this would be the 0.99 and this would be the 4. And so what's interesting is you could move this over here, in which case it would look just like this, would be equal to the fractional part of x. And so as a result, we could make that substitution if we wanted. I'm just going to make the observation for now and let it go. Again, so where do we approach this? How do we start? And it's very demoralizing for a lot of students. By the time you get here, it's a 75-minute test. You're probably almost running out of gas. You don't got a lot of time left, and you're feeling time pressure. Many students are just going to want to skip it. And so maybe if we just explore it a little bit, the problem will break down. And that's, in my opinion, exactly what happens. You have to persevere past a little bit of, I would call it as an analogy, thick underbrush. And then you suddenly break out into an open field, and it's a sprint to the finish line from there. But it doesn't come together right away. You've got to just kind of slog through it a little bit, and then you'll see what's going on. So let's get a look at it then ourselves. What can we do? What's the baby steps? Well, we got a variable, and you can plug things into variables. Maybe we should do a t-chart. Let's do a t-chart, right? If we want to explore a problem, we can say x and f of x. Now, again, x is less than or greater than or equal to 1. This is an extreme value, meaning on one end of our possible x values, x does not have to be an integer. It's all numbers. But we will start at 1 and see what happens. If I plug in 1, the greatest integer part will be 1. I'm going to get 1 times 2014 to the 1 minus 1. Well, that's just 0. So I'll just erase that so I save some board space here because we don't have a lot of it, and minus 1. Now, what is anything to the 0 unless it's 0? It's going to be 1. And so 1 minus 1 is 0 times this one, 0. Now, that's f of x. f of 1 is 0. What do we want f of x to be? Less than or equal to 1. This fits. Okay. But that would mean all integers, right? Because always this is going to be, if it's 2, for instance, 2 minus 2, 3 minus 3, and so on. And so all of those are going to be 0. We're always going to get 1. It won't matter what's out here because 1 minus 1 will be 0. So all the integer values would work, but they're infinitely small. They're not an interval. So we probably need to look a little bit farther. Maybe there's a value beyond 1, meaning the fractional part beyond 1, that would still work. And how would we identify that? And so what I like to do is I like to reduce complexity. I don't want to look at this. I don't want to write that. I'm trying to save time on the test, right? And so I'm going to just kind of put something in for this, like U, right? We're going to put the letter U. So I don't know why I always use U now, but ever since U substitutions in calculus, it's been my default thing to place in there. So you're going to have x times 2014 to the U minus 1. And what do I want? This is f of x, and if you want it less than or equal to 1, maybe I should just write that. Okay, cool. Now what? Well, if x is a number greater than 1, let's just say x is somewhere between an interval of numbers from 1 to something, but we don't know what. Just something beyond 1. We already checked what 1 was. This came out to be 0, by the way. So then how could we do it? Well, it doesn't matter what you put in between 1. Actually, we'll say this. It's on the interval from 1 to 2, but not including 2, but including 1. So no matter what, you're going to have this value be a 1. So for our intents, our purpose right now, we don't really need it, which means we can just move the 1 over here and we're going to get this 2014 to the u less than or equal to 2. Now, initially, too, I thought that since all of the intervals worked, I had a suspicion, and it didn't end up being true, but I like to have suspicions because then when you confirm them, then it feels more like you're on the right path, and so you kind of have an idea of where it might go. I thought maybe the integers were centers of convergence, like intervals of convergence, and I was centered on that integer in the middle of it, something like we would find in the various series when we're trying to find the interval of convergence in second semester calculus, or maybe it's second year of calculus if you're in high school. And so I thought maybe something like that's going on. So I thought maybe we're going to get infinite geometric series. You know, something like that where you have, I don't know, some kind of expanding interval size, and then something like that works out. I didn't know what to, expect exactly, but I thought that might be it. It didn't end up being it. Let's see what happens here. What do we have? We have some unknown value. We could say it's u for unknown. We have an unknown value in the exponent, which is kind of what logs are for, kind of, right? So we've got these answers over here with logs. You see that they're thinking about logs, meaning maybe we should think about logs. Let's take a log of both sides, and you have a couple options. You could take a log base 2014, and it would remove the entire thing here and just drop the u free. But I think I'm just going to do a normal log, right? Because these are log fractions, and it's kind of like an inference. We can kind of use their answers to go, well, if they're doing normal standard log base 10s, then maybe we should do that too. So let's go ahead and say that it's u times log of 2014 less than or equal to the log of, that's a terrible looking 2, log of 2. Okay, so if you don't know, the exponent on the 2014 can pull in front of the log. It's one of the rules of logarithms. You'll prove it in either Algebra 2 or pre-calculus in the United States and a different class elsewhere around the world. But now what we can do, we have a product we can just divide. So now we get that this u thing, which again, if you remember, this really is u. It's the fractional part of x, something between more than 0 and less than 1. I mean, it could be equal to 0, I suppose, if it was an integer that you're working with. Okay, but u will be less than or equal to log of 2 over log of 2014. Now we have to know what this really kind of is. How does it work? Well, think about it. This was the part beyond the 1. This is the fractional part, and it's certainly less than 1. We can tell because log of 2 is less than log of 2014. And so what can we do here? Again, if you think about it, we're on an interval, and we're looking for a union, right, of disjoint intervals. So how does this play into that interval? We kind of have to put it together. It's not quite apparent. Many of you it probably is right now. But we're just going to go, well, if 1 worked, and this is the part after the 1, that's the endpoint of the interval. That's the endpoint of the interval that works. It's going to go all the way from 1 to 1 plus log of 2 over log of 2014. Now, what is, actually you can include that value because it's less than or equal to. What is the length of this interval? Well, since you're starting at 1 and you're ending here, you just subtract. This is the length of the interval actually. And when that is realized, I think many students, if they're doing problem 21 and they're somewhat advanced at least, I think many students are going to kind of start to sense blood in the water, so to speak, like a shark, right? And they're going to kind of sense, okay, something's going on here. I'm seeing the connections between these. I've got this. This is actually my interval length. And now what they want to do is, because like I said, it's a time test, you have an average of 3 minutes per question on the whole test. There's 25 questions. Now, typically you're not going to take 3 minutes on number 1 and 2, so you earn the time for the later questions by being efficient on the early ones. But now we're going to want to kind of refine our process. We don't want to keep going with baby steps. We're going to just want to go like this. We're going to say it's log of 2 over log of 2014 plus. Okay, let's go to the next interval. What if I did an x value that started at 2 and went to 3? Okay, including 2 but doesn't include 3. So think about it now. I mean, in fact, we don't really need to see. Let's go back and erase this really quick. We don't really need, just keep that there. That front part is the greatest integer less than or equal to, and no matter what, if your any value including 2 to 3, this will be the 2. If your any value from 3 to 4, it'll be a 3, and for the 4, it'll be a 4, and so on. So for all these intervals of x values in between integers and possibly including the integer, this will always be the integer, 1 and then 2 and then 3 and then 4. And if we found a solution when x was between 1 and 2, it stands to reason we're probably going to get one for all of them. Probably, but not 100%. So we're going to have let's just put this down over here. Let's take this thing right here and divide it underneath, right? Less than or equal to 1, let's divide it. But it's always going to be an integer. And this time it's going to be a 2, right? And then if we add 1, we're basically going to get u times log of 2014 is going to be less than or equal to 1 plus 1 over the greatest integer that you were working with. Greatest integer less than or equal to. So as we work through these intervals and count up, this is just going to go up by 1 every time. It'll be 1 over 2, 1 over 3, 1 over 4. And when you add 1 to it, what will happen? What's 1 plus a half? It's 3 over 2. And the next time, it's 1 plus 1/3. It's 4 over 3. We now see a ratio of integers constantly increasing by 1. 1 plus 1/4 is 5/4, all the way up to the interval from 2013 to 2014. That means this game is going to end at 2013 which would it be end at? This was when it was 2. It was 3 over 2, right? So when it's 2013, it's actually going to end at 1 over 2013, and then 2013 like this. I'll just write it down. 2013 plus 1 over 2013, which is the form of 1 that we're using, all the way up to this. And of course, that's 2013 plus 1, which is 2014 over 2013. So if you don't follow, all of these are what we'll have here when we're in this position right here. This 1 plus. These values are those values as we work through the intervals. Again, we're trying to streamline the process. I hope I didn't lose you there. If I did, leave a comment. I will take the time to explain it within 24 to 48 hours. Okay, then what? Now we're going to divide by this log of 2014, and we know that u is the part after the integers that we always know work. Even while I'm doing the test, I continuously restate things. Why? Because short-term memory doesn't hold things more than about 7 or 8 seconds. And so you're going to have to kind of restate things to yourself to constantly reaffirm the knowledge that you've generated from the problem, right? We're not going to keep this knowledge long-term. It's kind of contained within the problem. But as we work through it, I like to restate things. You'll hear me do that when I lecture solutions as well. So next up would be what? If I'm doing the 3 over 2, that's this expression, but it would be in a log, right? I should have written that too. Let's write that. Sorry, just so I don't confuse people. It's going to be log of 1 plus 1 over that right there. And this inside, the argument of the logarithm is up here, okay? Okay, so now what? I've got a log of 3 over 2, and I'm going to divide always by log of 2014, always. So this will be plus log of 3 over log of, I'm sorry, not log of 3, log of 3 over 2. I keep making little errors like that. Over 2014, and then we're going to have plus and dot, dot, dot. Where is it going to end? It's going to end with this one, right? We're going to end with log of 2014 over 2013 all over log, I'm going to erase part of this so I have space, log of 2014, right? Every single denominator will be log of 2014 because it's always coming from this 2014 after we've moved the 1 over and done the logarithm and pulled the u to the front of the log. So it's always going to have that. But what do we have in the numerators? We have all plus signs, right? By now, I hope all of you have perceived we're well on the way to the sprint to the finish line part, and that's the kind of, it's like this wide open glade is what I say, right? You come through this underbrush and you're hacking away at the vines, and suddenly it's wide open and you just sprint. You just book it and just take what you've earned by exploring the problem a little bit and watching it break down. And so I really liked that moment in this problem. Really great job by the item writer. And so by now, if you know your logarithms, you know all your rules, you've got the plus signs in between, that means that all of their inner parts are going to end up multiplying. So you're going to have a log of 2 times 3 over 2 times 4 over 3 times ... times, and I'm going to put it as 2013 over 2012 times 2014 over 2013. And the reason I added the extra term in front is I wanted to just verify to myself that this is going to cancel that, right? And this one would have canceled in the previous term. So what we have left is the log still, and the 4 would have canceled down here, and it's log of 2014. And that's in the numerator. But the denominator is also log of 2014. Guess that means the answer is 1. The sum of all those intervals. This was the first interval, the second interval, the third interval, all of them disconnected. And so, yeah, you're going to see then the answer is going to be 1, log of 2014 over log of 2014. So I really hope you enjoyed this problem. Thank you for checking it out if you came from the newsletter, and if you did not come from the newsletter, please go give it a read. It's very fascinating. There's lots of neat articles in the realm of mathematics and creativity. And if you're interested, you should probably check out their conference next February in South Africa. The one that I went to had a lot of small group sessions where they spoke at the front of each of the sessions from different entities from around the world that were really very fascinating speeches and talking about what they're doing in the realm of mathematics education, creativity, and nurturing that process. So that's all I've got for you today. Thank you for checking it out. I hope you all have a wonderful day.